Hello friends, today's question: will the block move together or not? Also find the acceleration of the blocks. So this is a 3-block system having a weight of 1 kg, 2 kg and 4 kg, and a force of 24 Newton is applied to the 4 kg block, and the coefficient of friction is given as 0.5, 0.2 and 0.1. So we are going to find out whether they are going to move it together and what will be the acceleration. So first of all, let us find out the various forces that will be acting on the individual block. So we have this is 1 kg block. This is of 2 kg and the last one is of 4 kg. And on 4 kg, a force of 24 Newton is applied. So because of this force, it will try and move the 2 kg block towards the right. And let us suppose that force of friction between these two is Fr2, and because of that there will be opposite force Fr2 acting on the 4 kg block. Now this 2 kg block will try and move 1 kg block towards the right with the help of force of friction, and let us suppose that will be Fr1, and we have opposite force Fr1 that will be acting on the 2 kg block, and because of the coefficient of friction between the ground is 0.1, so there will be a force of friction here also, and let us call this as Fr3. So these are the forces which will be acting on the 3 blocks. So first of all, let's assume that all the 3 blocks are moving together. Okay. So we say that let all blocks move together with an acceleration which is given as A. So we can draw a single block whose weight will be 1 plus 2 plus 7, and the force will be acting on it as 24. Okay. And there will be a frictional force Fr3, and whose value will be equal to coefficient of friction 0.1, total mass is 10, and sorry, not 10, but it's 4. 10 is G and mass is 7, so we get this as 7 Newton. And it is moving towards the right with the acceleration A. So we can write the equation that 24 minus Fr3 is equal to mass into acceleration. Mass is 7, this is 7A, and from here we can say that 7A will be equal to 24 minus 7 Newton. So acceleration A will be coming as 17 upon 7 meter per second square. It means that all the boxes will be moving, or the blocks rather, all the blocks will be moving with the acceleration of 17.7 meter per second square. And if any of the box is not able to move according to this acceleration, then all the blocks will not be moving together. So we can see that this means that for all blocks to move together, they should have the acceleration of acceleration of 17/7 meter per second square. And if they do not have this value, then three blocks will not move together. So therefore we can say that acceleration of 1 kg block should be equal to 17/7 meter per second square. Acceleration of 2 kg should be also equal to 70.7 meter per second square, and acceleration of 4 kg should also be equal to 70.7 meter per second square. And let us find out now individual accelerations or individual friction value and compare that with the maximum friction. So let us find out for 1 kg block. So we already have 1 kg, and this is FR1, and it is moving with the acceleration of 17/7. So we can say that FR1 will be equal to mass into acceleration. Mass is 1 kg and it is equal to 70.7. So we get FR1 as 17.7 newtons. Now let us find out FR1 maximum. So we get the coefficient of friction is 0.5, mass is 1 kg and G is 10, so this is giving us a 5 Newton. Okay. So from this value we can say that our FR1 is less than FR1 maximum. So under this condition there will be no slipping between 1 kg and 2 kg block. So we can see that no slipping between 1 kg and 2 kg blocks. Therefore you can say that therefore box, rather we can say block 1 block of 1 kg will move with an acceleration of 17.7 meter per second square. Now similarly we find out for block of 2 kg, okay, and for block of 2 kg it is having FR2, okay, and there is a FR1 and acceleration A, which is 17/3. Okay, so we can say that FR2 minus FR1 will be equal to mass into, that is 2 into 17/3, okay, and FR1 we already know, so we can write this will be coming as 34/3, and FR1 we already know, FR1 is 17.7, so we can say that FR2 will be equal to 34/3 plus 7, my mistake, 7 plus 17.7, so this will be coming as 51/7. So FR2 is equal to 51/7 newtons. And once again we try to find out what will be our FR2 max. So FR2 max will be equal to coefficient of friction, that is given as 0.2, and mass is 2 plus 1 and multiply by 10, so this will be coming as 0.2 into 3 to 10, and which will be equal to 6 Newton. So we can say that FR2 max will be equal to 6 Newton. Now we make a comparison between these two values. So if we make comparison, we can clearly see that our FR2 is greater than FR2 max. So this means that slipping will take place between 2 kg and 4 kg Okay. Or we can also say that this means that the acceleration of the acceleration cannot be you can see this means the acceleration cannot be (17.7 meter per second square. Okay. So therefore, once again we solve it, and we find that this is 1 kg and this is 2 kg. So the force now will be acting will be of 6 Newton. Okay. And if they are moving together, let us suppose with the acceleration of capital A, so we can see that if they are moving together, with an acceleration of capital A, then acceleration of A will be equal to acceleration of 1 kg will be equal to acceleration of 2 kg. So it means this will be coming as 6 force and total mass is 3. So we get this as 2 Newton. Okay. And for last block, that is for 4 kg. So we have a 4 kg block. Applied force is 24, and here we have our FR2, and in this direction we have our FR3. So the acceleration of 4 A4 will be equal to, this is 24 minus FR2 is 6 and this is 7, so this will be 24 minus 13 divided by 4 kg, and this will be coming as 11 by 4. Okay. So this is for the 4 kg. For 4 kg there is a force applied 24, and we have FR2 of 6 Newton and FR3 of 7. So acceleration of 4 kg will be 24 minus 13 divided by 4. Okay, so we can say the acceleration of 4 kg will be equal to 11 by 4 meter per second square. So therefore, the acceleration of the 4 kg will be 11 by 4 meter per second square. Okay. Now here is very important consideration that the slipping between the 2 and 4 kg block will start if this condition is met. So we already know that FR2 max is 6 Newton. So this also implies that the acceleration of 1 kg plus 2 kg as they are moving together cannot be 17 by 7 meter per second square. Now this is because the maximum, or we can say available force which can drive 2 kg is only 6 Newton. Okay, because maximum force available is only 6 Newton. Okay, so now we see that if they are moving with acceleration A with the force of 6 Newton, so the actual acceleration will be coming as 2 meter per second square. Okay, so this is very important consideration, that the slipping is between 2 and 4 kg. The slipping between 2 and 4 kg will affect, or rather we can say impact, the overall acceleration of 1 as well as 2 kg, because the applied force on the 2 kg block will change. So that's why. So finally, we can say that the acceleration of 1 kg will be same as acceleration of 2 kg, which will be equal to 2 meter per second square, and acceleration of 4 kg will be 11 by 4 meter per second square. The second question, this is also a 3 block system, and it is given that there are find the acceleration A1, A2 and A3 of the 3 blocks. So this is A1, this is A2 and this is A3. If the horizontal force of 10 Newton is applied, first it is being applied on 2 kg block, then the B part it is on 3 kg block, and then C part it is on 7 kg block. Okay. So let us draw the various forces which will be acting on it. We can say that this is our 2 kg and this is our 3 kg, and finally we have our 7 kg. And in A part we say, or it is asked that for A part the force is being applied on a 2 kg block. Okay. So we have in this direction there is a force of 10 Newton. So because of this 10 Newton, it will try to move 3 kg block in the same direction. Let us suppose this is given as FR1, and we are going to have an opposite reaction to this FR1 on a 2 kg block, and this 3 kg block will try to move 7 kg block towards left. Let us call this as FR2 force, and we have here also FR2. Okay, so these are the forces which is acting for the first case when 10 Newton is applied on the 2 kg block. So once again we are going to assume that all the 3 blocks are moving together. Okay. So you can say let all the blocks move together with the acceleration A1. So the combined weight of this will be 12 kg, and we have a force of 10 Newton, and the acceleration A is, okay, and the coefficient of friction between the ground and the 7 kg is 0, so there will be no friction. From here directly we can find out that our 10 kg 10 will be equal to m into A1, mass is 12 to A1. From here we get A1 as 5/6 meter per second square. So it means all the individual blocks 2 kg, 3 kg as well as 7 kg should be traveling with the acceleration of 5.6 meter square if they have to move together. Okay. You can say that these blocks should be having an acceleration of 5.6 meter per second square to be traveling together or moving together. So we can say that acceleration of 2 kg should be also 5.6 meter per second square. Acceleration of 3 kg should be also 5.6 meter per second square, and acceleration of 7 kg should be also equal to 5.6 meter per second square. Now let us see whether individually they are able to maintain this acceleration or not. Okay, so let us first of all solve for block of 2 kg. For block 2 kg, we have this is 2 kg. A force is acting in this direction, that is of 10 Newton, and we have Fr1, and acceleration is given as 5.6. So from here we can say that 10 minus Fr1 is equal to 2 into 5 by 6, which will be equal to nothing but 5 by 3, and we get that Fr1 will be equal to 10 minus 5 by 3, so which will equal to 25 by 3, and we find out Fr max. Okay, so we find out our Fr1 max. The coefficient of friction is given as 0.2 multiplied by 10 multiplied by 2, so we get this as 4 Newton. So maximum force that is available is 4 Newton, whereas the required force is 25.3. So from here we can say that our Fr1 max is less than the required force. Okay, Fr1. So therefore slipping will take place. Okay, slipping will take place. Now, if slipping is going to take place, then we can find out what will be the So let me write it here again, that slipping is going to take place the condition that Fr1 is greater than Fr1 max. So this implies that slipping will take place between 2 kg and 3 kg. Therefore they cannot move. Therefore they cannot move with the acceleration of 5 by 6 meter per second square. Okay, because the required force is higher as compared to the maximum force that is present. Therefore, let us solve it again. So we have, this is about 2 kg. Now the force that is available only is 4 Newton and applied is 10 Newton. Let us suppose it is traveling with a 2 kg acceleration. Okay. So from here we can write that A of 2 kg is equal to 10 minus 4 divided by 2. This is not even 6 by 2. So we get acceleration of 2 kg will be equal to 3 meter per second square. Now let us solve it for block 3 kg. Yeah, 3 kg. So we have a 3 kg block. Okay, the force which is acting here is 4, and we have our FR2, and acceleration is 5 by 6. So we get the equation as 4 minus FR2 is equal to 3 into 5 by 2, which is 3 by 5 by 6, which is equal to 5 by 2. So from here we can see that FR2 will be equal to 4 plus 5 by 2, and which will be coming as 13 by 2. Now we find out what will be the FR2 max. So we say that FR2 max, the coefficient of friction is 0.3, and we have the weight of as 3 plus 2, that is 5, and into 10, so this will be coming as 15. Okay. Now the maximum available force is higher than the required force. So we can say that FR2 max, maximum required is greater, maximum force available is greater than required force. So we can say that from here, no slipping between kg and kg. Therefore, we can say that they will be moving with the same acceleration. Okay. Therefore, they will move with same acceleration. Okay, and let us call this as A2. Okay, so it means acceleration of 3 kg is equal to acceleration of 7 kg is equal to A7, and we can find out its value. This is about 10, and we have 4, and it is moving with the acceleration of A2. So we get 4 is equal to 10 A2, or A2 will be equal to 4 by 10. Therefore, the acceleration of 3 as well as 7 will be equal to 0.4 meter per second square. Okay, so this was A part. For the B part, Now the force is being applied on the middle block. Okay. So this is our 2 kg, 3 kg and 7 kg. Force is being applied on the middle block 10. So this will be trying to move 2 kg block towards the left. Let us suppose FR1. So we have here FR1, and 3 kg will also try to move 7 kg towards the right, towards left. Let us call it the force FR2, and accordingly we have opposite force here FR2. And in this case we also assume that they are moving together with the acceleration. Okay. So as the force is same, so we get that let they are moving with same acceleration. Okay. Same acceleration, and which will be equal to, let us call this as acceleration at A3. So A3 into, we have a weight of 12 and force is of 10. Okay. So we have A3 is equal to 5/6 meter per second square. And we can also draw the diagram. So we have, this is 12 and the force is applied is 10, and it is moving with the acceleration of A3. So it means all the individual acceleration should be at least 5/6 so that they will be traveling together. Now let us find out for individual blocks. So first of all is for block of 2 kg. This is 2 kg and the force that is being applied here is FR3. Okay, and we already know the acceleration, that is 5/6. So we get FR3 is equal to 2 into 5/6, which is equal to 5/3. Okay, and let us find out the maximum force. That is FR3 max will be equal to, coefficient is given as 0.2, weight is 2 and it is 10, so this will be 4 Newton. And from here we can say that our FR1 is less than FR1 max. That means the required force is less than the maximum available force. So therefore no slipping will take place. Therefore, thus the acceleration of 2 kg is 5/6 meter per second square. So we can write A 2 kg is equal to 516 meter per second square. Now let us find out for 3 kg. We can say for block 3 kg, so we have 3 kg block. The force that is being applied is 10 Newton, and we have FR1 and FR2, and acceleration is given as 5/6. So from here we can say that 10 minus FR1 minus FR2 will be equal to 3 into 5 by 6. Okay, so we can find out our FR2 will be equal to 35.6. And once again we find out what will be our FR2 max. So we can say that FR2 max will be equal to coefficient of friction is 0.3 and weight is 2 plus 3 into 10, and we get FR2 max is equal to 15 Newton. Okay, so the required, this means that FR2 is less than FR max. Required force is less than the maximum level force. Once again there will be no slipping. So the acceleration, can directly write now, acceleration of 3 kg will be equal to, that is 5 by 6 meter per second square. Now, next is our for block 7 kg. For 7 kg we have is 7 kg and the force is FR2 and acceleration is about 5 by 6. Let me check what was my, yeah, it's 5 by 6. Now in this case there is no friction between the ground and the block 7. Okay, you can say there is no friction between the block 7 kg and the ground. Okay. Therefore block 7 kg will follow block of 3 kg. So you can say that acceleration of 7 kg will be same of acceleration of 3 kg and which is equal to 5 by 6 meter per second square. One second. Yes. Yeah, that's correct. C part, we have now the force is being applied on the last block. We have this is about 2 kg, 3 kg as well as 7 kg. Force is being applied on 10 kg. So 10 kg will try to move 3 kg towards right. Let us suppose it is FR1. So we have here FR1 and 3 kg will try to move 2 kg towards right. So this is FR2 and we have here FR2. It's quite easy to solve now. once again they are moving together with the acceleration of, okay, assume let they move together with the acceleration of a4. Okay. So we have a weight that is 12, force being applied is 10, and acceleration is a4. So we can say that our a4, that is mass, will be equal to 10, and from here 4 you can say that a4 will be equal to 5/6 meter per second square. So it means at least all these should be having an acceleration of a4. So let us check for one by one now. First of all, we check for block 2. For block 2 kg, we have a force of FR2 and acceleration is 5/6. So our FR2 will be equal to mass into 5/6, that is equal to 5/3 Newton, and the maximum FR2 max will be equal to, coefficient of friction is given as 0.2, and we have weight of 2 and this is 10, this will be coming as 4 Newton. So maximum available, that is FR2 max, is greater than the required. So it means no slipping. So if no slipping is going to take place, the acceleration of 2 kg will be equal to 5/6 meter per second square. Now we find out for block 3 kg. So we have block of 3 kg. This is FR2 and we have FR1, and acceleration is our 5/6. So you can see that FR1 minus FR2, FR1 minus FR2 will be equal to 3 into 5/6, that is equal to 5/2, and from here we can find out our FR1, which will be coming as 5/2 minus FR2 was over 5/3. Okay, so this will be coming as 5/6 newtons. Now we find out our FR2 max. So we find out, sorry, FR1 max. FR1 max, we already have coefficient as 0.3. Weight will be equal to 2 plus 3 into 10, so this will be coming as 15 Newton. So from once again, the available force is greater than the required force. So it means no slipping. So if no slipping is going to take place, okay, so we have acceleration of 3 kg will be also equal to 5/6 meter per second square. Okay. Now last is our for block 7 kg. Now in case of this 7 kg, we can clearly see that there is no friction. Okay, so we can see that there is no friction between 7 kg and ground. Therefore 7 kg will follow 3 kg. Therefore acceleration of 7 kg will be equal to acceleration of 3 kg, and that will be equal to 5/6 meter per second square. So this completes the question. Thank you.